So right here, I have a piece of steel in the vise, right? And what I have done to start with is to drill a small hole in this piece of steel. Does not go all the way through, but it goes in probably 3/16 of an inch or so. It goes in there a little bit, just as a way to demonstrate that I was able to drill that hole. Now the other thing I'm going to do is to tighten up the vise, but file on this piece of steel and be able to see if the file is able to actually take away some of this material, right? And not surprisingly, it definitely is. Right? We can see that it's changing. What you could see before were the saw marks on the end of this. So I am changing those saw marks right now, and I'm also going to file away one of these edges so you can really see. It's probably hard to tell in the video, but there are little bits of metal coming off of it, creatively known as filings, little steel filings. Okay, so now I'll pull this out, bring it a little closer to the camera for a minute. You should be able to see there, hold on, there, that corner, that edge has been filed down. Right? It used to be straight across, basically 90 degrees with the axis of the object, and now there's that little bevel on the side there. Okay, so what that, just to prove that this metal is soft enough that I'm able to file it and drill a hole in it. Right now, I'm going to stop the camera for a minute and get set up, and we're going to try an operation on it. The next thing I'm going to do is to adjust the camera a little bit here and see that we're going to look right at those torches, okay? And I'm going to turn on these torches and use them to heat up that piece of metal, okay? My objective is to get the metal cherry red, really hot. So I have it cherry red. That should mean it's over 1350 degrees, critical temperature. And then I'm going to dip it in this water to quench it. You See a little bit of steam coming off there. Okay. And the water cools that metal off really fast. It's considered the most violent quench. You can quench using air, you can quench using oil. Different kinds of steel require different kinds of operations and desired outcomes, right? So now we should be able to tell a difference in the hardness of this piece of metal, right? I'm going to first pick a spot here on the side of the metal and do a center punch like I did previously. I think I'm going to do it. I have to take it on faith I'm doing this. Here, let's see. Okay. Might be hard to tell. Yeah, there's a mark there where I hit it, right on here. It may be pretty hard to see it in the video. I don't know if it made a really good center mark. Next, I'm going to try to drill it, and that's that little center mark right there. Okay, oh, so let's adjust the camera so you can see that better. And the important thing to look for is if I'm able to have material tear off, either with the drill, and I'll try the file again, like I did before heating and quenching it. Right? So here's my mark. Okay, so that is making a hole. Now let's try to file it a little bit. It's slipping a little bit. And from what I can tell, I am able to take away some metal. I'm not going to do quite as much as I did on the other side, but let's see where I am in the picture here. Okay, so I was able to take away a little bit of metal on that edge right there. Right there, that definitely took away some. This is where I did it before I heated it. Here's where I did it after, and it seems to be. So in other words, this piece of metal, this particular piece of metal right here, seems to be unaffected by the hardening. We're able to drill the hole before, and that's the, let's see, that's the bigger hole. We were able to drill this hole before we hardened it, right there. If you can get it, I don't know if it'll show there very well, but there is a little hole right there. And then after we hardened it, we're able to drill that hole right there. So this, apparently this piece of metal did not harden. So let's try a different piece of metal. Okay, here is a new piece of metal. I'm going to go ahead, I've already made a center mark there. I'm going to take my drill bit. And you should see that it was indeed the drill was able to make a hole here, and you could, in the video there, hopefully you could see the little pieces of metal coming out of it, coming from the drill bit, right? So I'll do a little bit of filing just for fun, just for the sake of uniformity. Sure enough, I'm able to file the edge of it as well. Let's see if it'll focus on that. Okay, I was able to file off that edge just a little bit. So let's go ahead and set up the torches again, and we'll heat treat this one, right? Okay. Yeah. Same routine, we'll fire them up. Okay, like before, we've got it cherry red right there. I'm going to bring up the water, put it in there. I'm stirring it around a little bit too, because one of the things that happens is it creates steam. When it creates water vapor or steam when you first put it in there, and that steam then actually creates a little insulating layer between the metal and the water, right? And what you want is maximum contact with the water for maximum cooling, right? So that's what the thing looks like. Now let's see if we've got it cooled off well enough to touch it. Yeah, definitely. Okay, so we'll put it over here in the vise and shift the camera over. Whoops. Now this is just silly. There it is. All right, so what we want to see now, I'm actually going to try to drill in the exact same hole where you remember there was metal coming out of it before. That is doing nothing. Try it here. And when I touch that, there's not even really a dent there. Just, if you look, you may see a little tiny silver thing there where I think it kind of polished the surface a little bit. but the metal itself is quite a bit harder than it was. I'm going to turn it this way towards the camera and put the file on it right here. And I can really feel the difference. When I'm pressing on that thing, the file is not giving resistance. It's more like, you know, like running your fingernail across glass or something. It just slides right along there. It's making, I think what it's doing is cleaning off some of this oxidation and stuff we created. But as far as actually removing metal, you know, nothing's happening. It's not generating any more metal filings. It's not creating, you know, that bevel on there. So if we look close here, again, we had the before hardening, we were able to file this edge here. We were able to drill a hole. Afterwards, you could see I tried to drill in the top. There's really no indentation there at all. And when I ran the file over here on it, it kind of cleaned off some stuff, but it really did not remove any of the metal. So what we've managed to do there is to harden this piece of steel. Now you might ask, well, we did the same thing with this one, and it didn't have the same effect. After we got done hardening it, same thing, heated up cherry red, dunk it in water. After we got done hardening it, we were still able to drill a new hole in it. Right, there was, let's see, the smaller hole is the one we did first. That, one of them, I think that's the one we did first, right there. And then after hardening, or heat treating, we were able to drill that hole there, and we were able to file it the same way. You know, that was from before, that was after, and we were able to file it. What the issue is, and the difference between these two pieces of material, is that this is a medium carbon steel. And it's made for making tools. You can actually take this and make it into a punch. You could make it into a chisel. You could do other stuff where a hardened piece of material is necessary. Right? So this is medium carbon tool steel, and this is actually mild steel, low carbon or mild steel, and it's not hardenable in its current state. You really can't harden it. You know, by heat treating it like we just did. And we proved that before and after heat treating, this responded pretty much the same to the drill and the file. This one, on the other hand, was soft when we started. I was able to cut it with a hacksaw. I was able to do all this other stuff to it. But after hardening, heating it above the critical temperature, 1350 degrees, and then quenching it, this became good and hard, right? Now, if we're actually going to use it as a tool, we might need to temper it. I'm not going to do that right now, but tempering it would involve heating it to a subcritical temperature, maybe about 450 degrees, and cooling it off slowly. And the temper takes away some of that hardness without taking it all away. Anyhow, so that's hardening a piece of steel.